Okay, so what I want to do quickly is I want you to just name these shapes for me. So in the chat, A, B, C, D, E. So these are the three-dimensional shapes that we are going to be talking about over the next 2 lessons. And I just want to make sure you also know what their names are. And then we'll talk a little bit more about some stuff about that. Yeah, so C is, yeah, Loretta, you're absolutely right. C is a cylinder. What about A and B? So A could be a cube. It's hard to know if these are equal. If these are all equal, then A would be a cube. Otherwise, we'd call it a rectangular prism. So now what is B going to be the same as? D is indeed a pyramid. And it looks like, yeah, so if these are all equal, that would be called a square-based pyramid. And I think I saw Lenovo said E is a cone. Has anybody got B yet? I haven't seen that anywhere in the chat yet. It's a triangular prism, yes. Triangular prism. So what's quite important, so first of all, there's the names. Now, each of these shapes is somewhat based on a base shape. And in the previous lesson, we spoke about what the base is. So in A, the base would either be a square or a rectangle. In B, the base would be a triangle. In C, the base would be a circle, and it's always going to be a circle for cylinder. For D, it actually could be a number of things. If it's a square, it's a square-based pyramid, but you could get a triangular pyramid. The base basically gives it its name. The pyramid is because of the triangles on the outside, on the lateral faces. And then a cone is kind of based around a circle. Now, for today, what you're going to need to bear in mind, we're going to focus basically on these top 3 shapes. And what you need to know about is how to find the volume of A, B, and C, and also how to find the surface area. And so whenever you are trying to find the volume, you're just going to say, what's the area of the base? And then times its depth, or sometimes what we call the height. It depends on which way it's facing. But for all these shapes, you basically have the base, you find its area, and then you times by the depth. For example, with a cylinder, the base would be pi r squared, and then times h, because the area of the circle is the pi r squared, the h is the height. Whereas if you had a triangular prism, you would first go a half base times the perpendicular height of the triangle, and then times the depth of that shape. Okay, so I just want to check, that's an important idea that we need to have in place before we start the lesson. So can you give me a thumbs up if you know how to calculate the volume of these 3 shapes, the cube, the prism, and the cylinder? If what I've said makes sense to you. Because that's going to be the first part of the lesson, is going to be finding the volume of these 3 shapes. And then the second part of the lesson is going to be something called the surface area. Now, I'm going to come to the surface area later in the lesson. So I'm not going to spend too much time explaining the formulas right now, but just to know that surface area is the amount of area on the outside. So when we talk about a cylinder, the area on the outside would be these two circles. And then you also have this bit over here, which we'll talk about later, which wraps around the outside. So that would be the problem of the surface area. The triangle would have the triangle on the top and the bottom, but it would also have these rectangles around the outside that we need to think about. And then with a cube is quite easy, because if it's a cube, all the surfaces are the same size, And so you would just find the area of one of the faces and then times it by 6, because there's 6 outside faces. But that will be for the second half of the lesson. Let's start with finding the volume and then see how that goes. So just to get the brains working, first shape or first question, find me the volume of this rectangular prism or this cuboid. And I want you to work that out. What is the volume of that? So we need the area of the base, and the base here. I mean, you could think of the base as this bit here, if you like, or you could think of the bottom part, but 4 times 3 and then times 8 should give you your answer in centimeters cubed. So it should be 96 centimeters cubed. And that would be A. Okay, so that's not too bad in terms of finding the volume. You find the area of the base, you times by the other dimension, or the depth. Sometimes we call this the depth. And that's all we really had to do there. Let's do one more of these. Find me the volume of that shape. What's the volume going to be of that? These are just like the warm-up ones. Okay, so the 6 times 2 gives me the area of this bit. And then this bit times by 8. And so you should get 96 centimeters cubed. Now, be aware, now that we're talking about volume, the unit that we're going to use is the cubic unit. And so what this literally means, when I say the volume is 96 centimeters cubed, it literally means that's how much space the shape takes up. And another way of thinking of it is there are 96 little cubes that will fit inside here. And each of those cubes, oh, I'm not a very good drawer at this, but each of those cubes is going to be 1 centimeter by 1 centimeter by 1 centimeter. And 96 of them would fit inside here if I stack them. Okay, so when we're dealing with volume, our units are cubic units. Which topic are we busy with? Botley, we're doing the topic of measurement. And today is, we're dealing with the shapes, the prisms and cylinders, and we're dealing with volume and surface area. Okay, well, let's try a slightly different shape. This is going to be my triangular prism. So my triangular prism is going to look like that. And I want you to find me the volume of this triangular prism, and you can vote in the chat as to what you think the volume is, using the ideas from the beginning of the lesson. My main tip is to think, well, you know the shape has a base, which is a triangle. Can you find the area of that triangle? And then can you find the volume by extending that triangle? Okay, so a half. So we are looking for the right angle. So a half times 3 times 4 gives me the area of this thing. But then in order for it to be a volume, I need to take into account, it's almost like Toblerone. There's a whole bunch of triangles behind each other. And so we times it by 9. And so you should get 12 times 9 times 0.5. And you should get, why is my calculator gone to sleep? Yeah, 54. and it's inches cubed because this was inches, and that would be option C. Yeah, so the good news is volume is actually quite straightforward. It's not, you just need to know the area. That's why the first lesson was about area, because you need to be comfortable with area. Let's go on to this one. So find me the volume of this triangular prism. And maybe somebody could even, this has a few little tricks in it. Maybe somebody can give us a hint. So if someone's willing to give us a strategy or a hint, maybe you can help us along with this question. Maybe you can, because it looks quite simple.
Rachel and Loreto say Pythagoras.
Aha, okay. I'm not going to say anything more than that, but I agree with you guys. I think Pythagoras is your friend here. Maybe I could ask you, Rachel, why do you think Pythagoras is helpful here? If you were willing to maybe tell us why you think Pythagoras is helpful. If you are, just pop your hand up. Otherwise, Loreto, if you're willing to share with us why is Pythagoras useful? Yeah, there we go. Loreto, why do you think Pythagoras would be useful here?
So we need to find the other side.
Exactly. Do you mean this? Do you mean this side over here?
Yes.
Why do we need that side?
It's the height.
Yes, because we don't have the height of the triangle. And so we needed the side that measured it. Perfect. Thank you. Thank you, Loreto.
Okay, sir.
Okay, so let's see what we get. So using Pythag, what are you guys getting? We should be getting 15 millimeters. So this is going to be 15. So that should be very helpful. So thanks for that help, everyone. Mrs. Siwe, thank you very much. 15, Watobe. So now the question is, what is the volume of this triangular prism going to be? What is the volume of this triangular prism going to be? So we go a half times 20 times 15 for the triangle part. And then we're going to go times 32 for the depth of the shape. So 0.5 times. And you should get 4,800 millimeters cubed. Yeah. So that's something to bear in mind. When you see triangular prisms, make sure that you've got I suppose you could use the area rule. Now, in this case, you needed to really find that 15. So you could have used trigonometry or Pythagoras to find that. But really, in the end, it comes down to 4,800 millimeters cubed. Okay, that looks pretty good to me from what I'm seeing in the chat. And so I'm going to move on to our third shape. Let's do this one first. So if we're talking about a cylinder with a height h and a radius r, what is the formula here that's going to help me find the volume? So which of these? So Kevin, at the moment, we're doing something called volume. And so we'll talk about surface area in the second part of the lesson, but I just want to make sure that we are comfortable with volume. So you're quite correct. The volume of this pi r squared times height. So the answer is going to be D. Perfect. So given that you understand how that formula works, here's a little mixture of a question. I want you to find me the volume of this cylinder. Now, this cylinder isn't giving you a radius. They're just giving you the area of the base already. I want to know which of these 4 options is going to be the volume of the cylinder. Now watch out for, there's some little tricks here. So be careful. Also look at the units. So you know that this is 87. But then to get the volume, it's almost like all these circles have to be packed on top of each other. So we get 87 is the pi r squared part. That's the area. Times the height is the 13. And we get 1131 centimeters cubed. So you should be getting B as your answer, 1131. And it's not centimeters squared because it's a unit of volume. Awesome. Okay. So all looking good. What I want to do now, guys, is I want to take these 3 shapes that we've got comfortable with, and I want to start putting them together. And this is what we call compound shapes. So you're going to find me the volume of a compound shape like this. So can you find me the volume of this shape, bearing in mind that this calculation will incorporate 2 parts? It's incorporating a rectangular prism and a cylinder. And so I want to know, what is the volume? How much space does the shape take up, bearing in mind that the middle part is missing? It's almost like someone stuck their arm through. And so this part is not part of the volume. Can you find me the volume of this shape? Yeah. And if anybody would love to share their thinking on this, I'd love to hear what your plan is. Maybe somebody could share their plan as to how they did this question. Then pop your hand up and you can, let's have a look. Maybe, Muzi, would you like to share your plan for this question? What do you think we need to do in order to find this? Or Shane, would you be willing to just give us some, not the whole thing, but give us some guidance as to how we think about this question? Yeah, I'll go to Shane. Shane, what do you think we need to do here? Can you hear me, Shane? Can you hear me? It's very faint. I can't quite hear Shane clearly.
Oh, wait, I'll type it in the chat. Oh,
hi, Shane.
Hi.
How's it going? What are you thinking about? What's your thinking here in this question? What do you think we should do?
Calculate the volume of the cylinder inside of it and then subtract it from the total volume.
Perfect. So you basically find the bigger outer shape and take away the inner shape. Would that be fair? No. So 20 times 22 times 4 gives me the outer shape. And then the inner shape is going to be pi r, which is 2 squared. So the outer shape, the rectangular prism, is length times breadth times height, minus the inner cylinder, which is pi r squared. Sorry, I left out one bit. Pi r squared. And how deep is this going to be? Maybe someone can help us in the chat. So I know I need my pi r squared, but I also need how deep it is. Ah, Lasedi, yes, it's 4. Okay. What's my final answer going to be there? So I'm taking the big outer shape and I'm taking away the inner shape. Yeah. 1709.73, and that would be meters cubed. So Kakleko, the reason it's 4 is if you imagine that shape in the middle, it has a certain amount of depth to it. It's like how many circles behind, how deep is it going? And that's going to be 4 because of this 4 over here. This is sort of showing you how thick the block is that the circle has been taken out of. So does that help a little bit, Kakleko? This idea that 4 is here, it's the same 4 that's coming through here. That's how deep it is. Yeah. So thank you for the help there. That was really good. And yeah, I think you definitely are striking me as being reasonably comfortable with compound shapes. And so I think I want to try another one like this with you. And a quick vote, if you're feeling okay, thumbs up if you feel okay with the pace, thumbs down if you're feeling a little bit like it's going too quickly. Just want to get a feel for the room, because obviously in digital land, we can't always see your lovely faces. And so we have to use the voting machine. I like, yeah, some people are in the middle, which I like to. Okay. Okay, so there's a little bit of a mixture. Okay, and some people are a little bit slower. Okay, yeah, let's slow the next one down a little bit. So in this next one, you are finding me the volume of the shape, but the middle, it's almost like you have a cylinder and the middle cylinder has been cut out. And you have 2 radiuses. You have the radius of the inner cylinder, which is 12, and you have the radius of the outer cylinder, which is 20. I want to know, what is the volume of the shape, bearing in mind that the middle part is missing? And so I know I'm going to let you kind of do the solo, but if anybody would like to give us a hint, maybe they've seen a problem like this before, what's a good idea to do to plan your strategy here? Because it's almost like a cylinder that then has had something removed. What process or strategy could be helpful in this case? And so if you have an idea, I'll leave it open to you to put your hand up, or you can put it in the chat and I'll read it out for the class. Because there is a particular strategy we use with this type of question. Who has an idea about what strategy would be good? How do we deal with shapes that have lost some of themselves?
I like that. Lost some of
Yeah,
themselves.
Exactly. It's like we've taken a piece of them away.
Come on, guys. Any hints?
Any ideas? If I look at the previous question, it looked to me like we subtracted to get rid of. So it's almost like we assume that it's full, and then we take away what is missing. That's the way I would think about it. And so since these are both cylinders, I was thinking, well, let me start by writing the formula for the volume of a cylinder and just leaving blank spaces. Maybe that can then help me as I go about this journey. Well, let's even start with this question. What is this value going to be? It's going to be the same value. And in the chat, if you could tell me, what do you think that value is going to be? Yeah, this is going to be 22, because it's this thing. It's how tall, and both my cylinders are 22 centimeters tall. Yeah, perfect. Okay, what do we think is going to go here? This is the big, and this is the small. So what is that going to be? What's the blue going to be? What's the green going to be? So the big is going to be 20 L, and then this bit is going to be 12. Yeah. And let's see what we get for that. I see Ethan, Abnejo, Boitumelo, Loretta. Guys, you all, I agree with you. You get 13,693.45. And that would be centimeters cubed. So are there any comments or questions? I just want to open the floor. The strategy of big minus small or big plus small is a common strategy when you have these shapes. So if something is missing, you normally have to subtract it. If something is added on, you normally need to add it. And so I just want to point out, because you're going to see other shapes like this, these compound shapes are quite popular. Are there any questions in the class? Okay.
Mr. S, normally how many marks would this kind of question be worth?
So this is probably about a 5-mark question. So I would probably imagine you'd get 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. Yeah. So about a 5-mark question. Yeah. Cool.
Thanks, Mr. S.
Pleasure. Let's try. Actually, let's not do this one. Let's do this one. And then we'll, I think after this one, we'll call it a day for volume. Find me the volume of this shape. Find me the volume. And again, if you have a strategy that you think could be helpful here, I want you to put it in the chat, or maybe you can raise your hand. What strategy would you use? Otherwise, get cracking and see if you can find me the volume of this shape. So for this shape, for this question, Katlego, I would say, oh, well, let's get the answer first, and then I'll show you the mark allocation, roughly the mark allocation.
Mr. S, a question from Kevin. Is there a hole in this one?
Is there a hole? There isn't a hole in this one. This is like one of those ones where we stick something onto something. So this one, we have, that looks to me like a cube because all of these are equal. So we have the cube, and then stuck onto the cube is a cylinder. And so because we're asking for the volume of the shape, what we need to do is we need to think about how do we bring two volumes together. That's the hint I'm going to give you. There is a hole, but when we talk about volume, it's not emptying out. It's not like it's been drilled through. This has just literally been stuck on. Ah, I love it. Let's say these questions. Is 5 the diameter or the radius? And that's an important question. This is 5 is the diameter, which is not strictly what you need. What you need is the radius, if I remember the formula correctly. And what I like to do, guys, is I like to kind of think about, I know that I'm going to be adding these two things together. And so I ask myself, what does the first shape, formula for volume look like? And then what does the second shape look like? And I think it'll look something like that. Shane, I'll work it out in a moment. Let's see how it goes. But I'm pretty confident we have a cylinder plus a prism. This is pretty straightforward. It's 15 times 15 times 15. This takes a bit more work because the radius, so if the diameter is 5, the radius must be 2.5. So we have 2.5. And then the depth of the shape is going to be 30. Because of this, this is basically how deep it goes. So let's see what the final thing we get is going to be 15 times 15 times 15 plus pi times 2.5 squared times 30. And we should get 3964.05. And that would be centimeters cubed. Okay, so if you look at what we're getting to already, we're getting to these things called compound shapes. And the good news is you only have two variations. You have the variation where something is missing and you subtract, or you have the variation where something is added together or it's stuck together, in which case you add together. But the pieces that we've talked about, these are all just pieces that we learned about in simpler questions. And we just have to ask ourselves, are we adding them or are we subtracting? So for volume, these calculations are fairly, I don't think they're horrible. And as you practice them, they become a lot easier to use. Okay, so it is break time. And I want you to be on your feet, and I want to see some stretching. And so, Lebo, if you could please assist me in encouraging the students. Let's see who has got the best. Well, even if you're a bit of a dancer, then I mean, I'm not a dancer, but
you can show us some moves. Come on, guys.
The last lesson we had a little dance, and it was, to be honest, it was amazing.
Yeah, there's a bit of a dance off there.
Yeah. Oh.
So Loreto joined in. Pusisiwe. Come on, guys. Give your body a break.
There must be some pollen or something, because around this time of day, my nose always gets blocked. I have no reason to, don't know why.
Oh, really?
Like a pollen count or something.
Yeah.
Anyway. So
Letu, Mason.
There we go, Letu. Investing in yourself. I like to see it.
Yes. Sitting for 30 minutes is no joke, guys.
All right. And while you are finishing off your stretching, here is our brain break for today. So can you figure out what a Christmas tree plus a ornament plus a teddy bear in a box is going to be equal to? Let's see what you can do. Aha. You guys are off like a flash. So I agree this is 5. So that's 5. And then I agree, Loretta, the box is 7. Which means Barbara has correctly concluded that this is 13. So what is my final answer going to be? Abnejo, Letu, Rachel. I agree, 5. It's pluses, so it's not particularly hard. So this is going to be 25. Winning at life. There we go. Yeah, it was. Today's one was easier. It's kind of hard to find the Goldilocks thing. Ethan, what's with the teary eyes? Is that because it happened so fast, or? Yeah. Cool. All right. So I hope that your stretch was good. And so in the second half of the lesson, what we're going to do is we're going to talk about, is that what the tears were about, Ethan? I see. We're going to talk about surface area. So we've done these 3 shapes. However, there needs to be a slight adjustment for surface area. And so let's start by talking a little bit about that. Clearly, this is a rectangular prism. If it was volume, it'd be a piece of cake. For surface area, there are actually 2 ways you can find the surface area. And I'll talk about that in a moment. But I just want to see if you guys can figure out the surface area of the shape. And then if we've done that, I'll show you the 2 different ways, and you can decide which one you like more. I have my own preference. I'll explain why in a moment. But first of all, let's just see, can you find the surface area of this rectangular prism or this cuboid? In fact, I'd actually be interested to know the different methods in the class, because some of you will have learned either of these methods. So once you've put your answer in, maybe you can even share how you found the surface area. The surface area is basically the outside area of the shape. So it would be this, and then below, it would also be this, and the back part of that, and so on. But there's different ways of finding it. Let's see what people get. I'll put your M1 for method 1 and then M2 for method 2. In fact, I'd love to hear from the class. Would somebody be willing to explain their method? Maybe we'll get both methods. So pop your hand up if you're willing to explain how you got the answer. It seems everybody's got to B. The way I would do it is I would go 2 times 3 times 5 plus the perimeter of that base. So that would be 3 plus 3 plus 5 plus 5 times 8. And so what would I get? 2 times 3 times 5 plus 16 times 8. So I would get, why am I getting 158? Let's see the other way of doing it. 2 plus 2 plus 2. And so this would be 3 times 5. And then
Mr. Ellis?
Yeah.
Maybe you can explain the unseen bits.
Yeah, no, I'm getting it in a moment. I just want to make sure the answers are the same for both methods, and then we'll have a look at that. And then 3 times 8, and then 8 times 3, and then this one will be 5 times 8. Let's just see I get the same answer. So 2 times 15 plus 24 plus 2 times 40. Okay, the good news is both methods give us 158 centimeters squared. And so the reason I'm doing this, okay, everyone, clearly we want to talk about what it means to find the surface area of the shape. And so that's why I did this multiple choice question. So let's go through what it means to find the surface area. The surface area, the one way of doing it is to think about how many different faces are there in a rectangular prism or a cuboid. And if you think about it, there are actually going to be 6 faces. So the one is facing you like this and here. And so that would be like this one over here, 2 times 3 times 5. I doubled it because there's 2 of them. Then you also have the 5 times 8. So the 5 times 8, which is the bottom part here, that rectangle at the bottom is 5 times 8, but there's a matching partner up here, which is 5 times 8. Okay, so that would be this one over here. And then this one over here, what rectangle is that going to be? It's going to be the one facing you here. So it's going to be 3 times 8 over here. I don't know if I've... So that's the way where you double. You basically find each of the rectangles and you double them. So that's the one way of doing it. So give me a thumbs up if you understand what I did there, because I'm going to rub it out the coloring in. I'm going to show you why the other method works too. But I first want to see you guys understand how I got that surface area. Okay, awesome. Now, that does work. There's nothing wrong with it. You're basically doubling the rectangles. But another way of doing this is to say, okay, why did this one work? 2 times 3 times 5. Now, what I did with this one is I said, what is the area of the base? I'm calling this the base. And so there's 3 times 5. And now, because there's 2 of them, that's this part over here. But what about these other 4 rectangles that we have attached to this? So if you imagine, I still need to take into account that rectangle over there and that rectangle over there. So imagine like those 2 over there. And then I also need to take into account this rectangle on the bottom, which goes like that. Like that. Now, this way is quicker. So what we do, I'll tell you the formula. What you do is you double the size of the base, and you then find the perimeter of the base. So in this particular shape, the perimeter of the base is just this. It's 3 plus 5 plus 3 plus 5. So that's what I was doing over here. And then what you do is you multiply by how deep it is. And how deep is it? It's 8 things deep. Now, the reason this works, the reason it works is that if you imagine me multiplying these things out, you would get 3 times 8 plus 3 times 8. Let's zoom in for a second. Plus 5 times 8 plus 5 times 8. And what those things are doing is they are all the 4 rectangles that are wrapped around the outside of the shape. So you can imagine a rectangle here, here, on the other side, on the bottom. The first step took care of the 2 blue ones over here. So those are your 2 choices. You can either use the pairs of rectangles and double them, or you can use this method where you find, Botley, I'll explain again now. In method 2, what I did was I said, I chose a base, which was this front blue one. And I said 3 times 5, and I doubled it because there's 2 of them. Then I said, for the second part, I said, what is the perimeter of the base? An original blue base. And the perimeter is 3 plus 3 plus 5 plus 5. That gives me the outside of that base. And then I just multiplied it by how deep it was, which was the times by 8. And what I'm really doing when I do that is I'm basically adding up 2 rectangles over here, and then I'm adding up 4 rectangles over here. Now, what I suggest we do is we practice this, and you'll see which method you like quicker. But what I know about this method is it works really well for triangular prisms as well, and it can speed things up a little bit. So let's try out both for a bit. Find me the surface area of this rectangular prism over here. So it's got dimensions 6 by 2 by 8. And I want you to find me the surface area of this shape. And I will show you using method 1 and method 2, and then we'll see which one you think is easier, or which one you like more. And then if there's a question, I know with a new method, maybe there's a question, someone can come along and ask that question. Otherwise, let's see what you can do here. Can you find me the surface area of this shape? Where's this one? So I'm going to choose my base to be this. So we could have 2, and then we could have 8 times 2, then 6 times 8, or we could just go 2 times 6 times 2, which would be doubling the area of the base. And then I ask myself, what is the perimeter of the base? Well, it's just going to be 6 plus 6 plus 2 plus 2, because I'm basically going around the outside of my shape. So 6 plus 6 plus 2 plus 2. And then I times it by the depth, or the other side that I haven't used, which is going to be 8. And both of those answers should give me, let's have a look, 12 times 2 plus 12, 16. I get 152 centimeters squared, or both of these? So which method do you guys prefer? Can you tell me in the chat? I do know once you get comfortable with this method, it is faster, but if you're not comfortable with it, just see which one you prefer. Okay. Most of you seem to prefer method 1. That's completely fine. Okay, so let's move on. So the advantage of method 2 is I'll show you in the triangular one, it may become more helpful but let's move on to the triangular prism. Okay, we've got about 10 minutes left and we're going to finish off with, I think, the triangular prisms area. And I want you to try and find me the surface area of this triangular prism. And again, I'll show you both methods, but let's just think about the surface area. What are the different things that are in play here? There's definitely 2 triangles, but what are the other shapes that are involved? And I want to see if you can get it. So over to you. And then Lebo, are there any questions that I'm missing or students maybe?
Not at the moment, Mr. Ace.
Okay. So we're trying to find the surface area of this triangular prism. I'll do method 1 and method 2 again here, just to keep us open to all methods. Oh, we've done quite a lot today, sure. That's going to be So method number 1 basically just takes the 2 triangles and doubles. Well, the triangles are identical. These are congruent triangles. So I double that triangle to take care of that. But then I still have to add up all the rectangles. And there's 10 times 7, 10 times 7, and 10 times 8. Or with method 2, you do the same first step. And in the second step, all you do is ask, what is the perimeter of the triangle? And it's just going to be 7 plus 8, which is there. And then you times it by 10, which is the base. Can you see how you get the same thing in the end? And so your final answer should be 8 times 6 plus, that is going to be 22 times 10. And you should get 268 centimeters squared, which would be B. All right, so again, both methods give us the same answer, and you can see if I multiplied out the 7 by 10, the 7 by 10, the 8 by 10, both methods will work here. Should we squeeze in one more, guys? I feel like you're doing so well, we can get one more in here. How are you feeling?
I think so too.
I'm
They're doing great.
well enough today. Are there any questions about the methods and how we found the surface area of the... Kevin, it's completely fine if you draw a net of the shape first. In fact, I've got the nets here, if you ever want to look at them. So basically, when we unfold the shapes, that's what they look like. And the only one we haven't spoken about surface area is the cylinder. And we see that the cylinder is actually just going to be a circle on the top, a circle on the bottom, and the bit that wraps around is going to be a rectangle. So that's something we'll talk about in future lessons. Let's go back to one more question here, and then we're going to call it a night. So find me the surface area of this triangular prism, and then we'll call it a night for tonight. And we will talk a little bit more about the surface area of a cylinder in the next lesson. What is the surface area of this? Lebo, which method do you think you would use if you were back in grade 11?
I think I like the first method.
First method, okay. Yeah, the second method feels a bit like magic. It's like, how is it working? But yeah, no, I agree. It's... Okay, so I know I'm going to have to double the front and back triangle. And it seems to me like that would be a half times the base times the height. So no problems there. And then I've got to get my three rectangles that are going to be 7 times 12. And I got the other one, which is going to be 3.5. Oh, wait, the other one is also going to be 7 times 12 because these are equal. These two are equal in size. So I'm going to get 7 times 12. And then I've also got to worry about this bit, and that is 3.5 times 12. So in terms of that method, you can see that all of those rectangles have a depth of 12. That's why that other formula works, because you always have the same 12. You basically, yeah. Okay, let's see what I get for my answer. Okay, I am half 7 times 3, 0.5 times 7 times 3, plus 7 times 12, plus 7 times 12, plus 3.5 times 12. I get 2. Why is everyone getting different answers to me? I get 220.5 centimeters squared. So guys, have a quick look here, because quite a few of you are a little bit off there. The base of this shape is 7, and the height is going to be 3. So that's why I've got half base times height over here. But what have I left out, everyone? You're quite right. This needs to be doubled because of the front and back. So that's why my answer was off. Well done. Well done, everyone. So you double that first one, and that's because of the front and back triangle. And then you have your 3 rectangles. So you have 0.5 times 7 times 3 times 2. I knew something was going on. I could see there was too many. Plus times 12. You should get 231 centimeters squared. Okay, so If you had used the other method, you would have just found the perimeter and so on, but I know that the final answer is 231 centimeters squared. Okay, Loretta, I'm so glad. Also, it's such an ironic thing that if a teacher makes a little slip, it's funny how students tend to learn more from that as long as it's corrected than if I just told you the right answer. Something weird about our brains. We just remember the difference. So yeah, guys, you've done really, really well. And so what I want to ask you to do now is, Lebo, if you could please put the link to the quiz. If you could please give the quiz a go. And yeah, we did a solid amount of work today. If you look at the first half of the lesson, it was volume. The second half of the lesson was finding the surface area of triangular prisms. And the only thing that we didn't get to was the surface area of a cylinder, which we'll talk a little bit more about in the next lesson. But yeah, I hope that you enjoyed the lesson today. And yeah, feel free to go off and do the quiz. It shouldn't take you very long. It'll be like 5-10 minutes max. Otherwise, if there are any questions from the class, I'm happy to answer those now before we finish off. But yeah. Yeah, Anel, what's your question?
Sir, can you please explain again how you got the 231 centimeters squared? Okay,
cool. So do you agree with me that the two triangles are important? So the first thing I have to do is find the area of the front and back triangles. Anele, are you okay with that bit?
Yes, sir.
Okay, so the area of one triangle is 1/2 times 7 times 3. So that's one triangle. But because there's one here and one here, I have to times it by 2. So you with me on that so far?
Yes, sir.
Okay, now we have to worry about the rectangle on the bottom, okay, which is going to be 7 times 12. We also have to worry about the rectangle. Let me see if I can get a different color here. That is facing us straight in front. So almost like that there. That's also going to be 7 times 12. And then the last rectangle that I need to worry about is the one that is 3.5 times 12, which is down here at the back, which is that one. And so we add all of these together. Does that help, Anile?
Yes, it does. Thank you.
Pleasure, man. Absolute pleasure. All right, everyone, I'm going to wish you well as you go and do your quiz. And yeah, we will see you on Monday. I hope that you had a good lesson. And yeah, let us know about if there's anything that you still want to deal with later in the next lesson as you leave. Or yeah, feel free to express how how the lesson went for you.
Mr. S?
Can I go back to the
Yes.
back to the volume formulas? Okay. The volume formulas were, think about these ones. So let's have a look. These were the volume formulas that we got at the beginning of the lesson. Then remember, we were building the surface area ones, and the surface area formulas, you basically have to just go around the outside of the shape and add up the exposed areas, really. Shailen, you can squeeze in one question. Yeah, that's fine. Just raise your hand and we'll do our best. Pleasure, Sarah. I'm glad I could help. So Shailen, do you know how to raise your hand? We can.
Oh, she's unmuted.
Okay. Hi, Shailen. What is your question?
Hi, sir. I wanted to ask, sir, can you please go over the question that we did with the cylinder of the outer shape and the inner shape? I didn't quite understand that one.
Okay, let's have a quick look at that. So that was, where was this one? Here we go. That one over there.
Yes, so that one.
Oh, sorry, this one over here. So the one with the
that
12.
one at the bottom. Yes.
Yeah. Okay. So the main idea is if we had just done the first one, okay, if we pretended this was filled in, all we would be worried about is this part. Because it's a solid cylinder. Nothing is missing. And the radius that would be most useful to us then would be this one over here. So are you with me on that part?
Yes, sir.
Okay, now imagine you basically use like a drilling machine and you drill around here. And so now you have to subtract the volume of the cylinder inside. Now, what is the radius of that cylinder? It's actually just 12. And so that's why that's 12 there, whereas this over here is 20. And so you almost take the big volume, take away the little one, and what's left is how much volume this empty shape takes up, or sort of empty. Does that help a little bit?
Yes, sir. A little bit. So you're saying you took the volume of the whole cylinder without it being drilled and subtracted it by the drilled amount.
Yes, exactly. It's almost like I took like a drill and I drilled through the middle, and now that volume is no longer part of the shape. And so we have to subtract it from the whole shape, which is different to a situation like this, where we added extra volume to the shape. We didn't drill through. That's why we're adding.
Oh, okay. I understand, sir. Thank you.
Perfect. All right.